add symbol and I will give this test. So this is same as doing this one. Now this is the whole idea of decorator. You write a function that enhances the behavior of the class and you get a modified class on which if you create object you will get some enhanced functionality. So this is whole idea of decorator, and this is how we write a decorator function, where we are calling the function manually, getting a new class and creating advanced object from that advanced class. So this is just a syntactic sugar in loose terms. Loose term means not exactly this is how it happens, but just you are watching TypeScript Masterclass, and today our topic of discussion is decorators. So what are decorators? So I believe decorator is one of the most powerful tool given in the TypeScript toolbox. With the help of decorators, we can modify the behavior of class and its members. And remember, decorator is only applicable to class and its members. Like directly I can attach a decorator to the class or to the class parameters or to the getters and setters or to the class method. A lot of framework like Next.js and Angular, they heavily use the decorator pattern to give functionality to the developer. So you can package certain piece of functionality into a decorator, and once you add it to a class or its members, it will enhance its behavior in a certain way. So this is what we are going to deep dive into today. So first let us start with class decorator. Now just like the previous video, in this video also we are going to use the same starter template or the base code. Link I have given in the description, and also the completed code, that link also is given in the description. So if you are stuck anywhere, you can check either the base setup or the completed project. So here I have created a folder called decorator. Here I will add a new file and call it as class decorator.ts. Now most importantly, when you are working with decorators, you have to come to tsconfig, and here you have to uncomment this one, that is experimental decorator true, and this one emit decorator metadata. So these two things you have to uncomment it and make sure that the value is true, otherwise decorator functionality will not work. Then what I will do here I will add a console.clear statement, so that in the console when we run something, it will always clean the console and display, so that our console will not be cluttered. We will always have the clean display to look at. We will start with class decorator. So what exactly is a class decorator? So decorator is nothing but a function. It's a simple function. So if I have to write a function, what I will do, I will use the function keyword. So let us start with that. So I will say function, and let us name it as test. Of course we will give some meaningful name later, but for now just let us see what is the inspiration behind the particular syntax that we use to define a class decorator. So decorator is nothing but just a function. So I have created a function and I am giving it a body. Then I will create a class. So I will say class employee, and I will keep this as empty for now. And what I will do, I will say const employee equals to new employee. So we have seen this previously, and a prerequisite for understanding decorator is that you must understand object-oriented programming, because here we are going to extensively use class inheritance and all the class related properties like getters, setters, params and methods. So I have already made a video about object-oriented programming in TypeScript. If you want, you can refer that, or if you already understand the concept of object-oriented programming, then let us continue discussing decorators. Now this is going to take some parameter. So what parameter it will take? So let me call this as class entity and it will be of type employee, so that I can work with the employee class. Right now, if you see here, what is this class entity? And before this, let me call this function and let me pass employee. Now, if you see this test function, what it is taking? It is taking a object of type employee, and this is what we are sending on line number 10. That is, we are calling the test with the employee object. Now, what distinguishes a decorator function versus a normal function? So now, for example, if I add a property here, okay, so I will say public name, which is of type string, and I will mark it as empty. Now, since I am passing the employee object here, if I check this class entity, this will be the object which has the property name. Now, what distinguishes a decorator function to a normal function is that inside the decorator function, I don't want the object, but I want the class itself. That means here I should be able to do two things. One is to be able to create another class by extending this class entity. So I should be able to say class new class extends the class entity. Of course, it will throw error. Then what else I should be able to do? I should be able to create object. So I will say entity equals to new class entity. So this is what I should be able to do in my decorator function. That means I should be able to extend the class, or if I want, I should be able to create the object from the class. Now, why it is giving squiggly? Because if you see, this class entity is an object of type employee, or technically this class entity is an instantiated entity. What do I mean by an instantiated entity? That means the entity has been instantiated from a class. That means it is of type object of a particular class. But for this decorator function, I don't want an instantiated entity, but I want an instantiable entity. So what do I mean by an instantiable entity? That means it's an entity on which I can create an instance of. So here I should be able to create an instance of this class entity. So here I simply don't want the object, but I want the class definition itself. Here in test, I don't want to pass the employee object, but I want to pass the employee class itself. So if I am able to do this, then this will be counted as a decorator function. Now, how can I do this one? So instead of simply saying employee, what I have to say, it will be new, then parameter, then arrow, then employee. So now this has been converted from an instantiated type to an instantiable type. Now if you see, all these squiggly are gone, and I can create a new class that extends the class entity, which means this employee, and I can create a new entity from this particular definition. So these two conditions are now satisfied. So this is the first step in writing a class decorator function. Of course, there are a lot of things that we have to do. Then here, what if, so I have hard coded it as employee. Now what if I will write another class, call it as student, and I should be able to pass student to the test. So can I do this one? So let us say test and student. Now let me also run the project. So the project is running. Now if you see here, I am able to pass student as well as employee. Now why it is that? Because this employee has a name and so does the student. That means TypeScript will check the common properties between two types, and if there is a commonality between these two, it will accept both. So instead of in the student, instead of name, let me say roll number. So as soon as I added roll number, now this employee class params are completely different from the student class params, right? So that's why you immediately get squiggly. And what it is saying, type of student is not assignable to type new employee. Okay, so how to fix this one? Instead of hard coding it as employee, I will mark it as a generic object. So now it will take employee, it will take student, and it will take any object that I can think of. So this is the next step. Then what if there is a constructor? So I will add a constructor with some parameters. So I will say name, and in constructor I will say this dot name equals to name. And why it is giving squiggly? Because I have to give the type definition. And same thing I can do for this student. So I will take the roll number and I will mark it as string, and here this dot roll number equals to, I will say roll number. Now if you see, all of these are now giving squiggly. Why this employee is giving squiggly? Because the constructor expects one argument, I'll pass a empty string. Now why these two are giving error? So if you see, it is saying new empty parameters and a class. So here it is saying you are passing some parameter to the constructor, but according to your definition it doesn't take any parameter. That's why it is giving squiggly here. So to fix this one, what I will do, I'll pass the generic argument, just like how I created a generic class. That means it will take any class. So here I should be able to pass any number of arguments. Here in my example there is one parameter. It is also possible that there might be multiple parameters. So how to take that into account as well? So I will use args, which is of type any array. That means you can pass any number of arguments of any type. So now if you see, this squiggly is gone, right? So we have our test class ready, and what it is doing, it is extending. I'll remove this new entity. Okay, and here what I will do, I'll try to add some additional functionality. So this is a class that is extending from my base class entity. So it can be an employee, it can be a student. So here I'll add a constructor, and what this will take, this will take the arguments of type any array, and here in the body I will call super and pass the args. Now what I want to do is, I'll add a console log. That means every time this object is created, it should display in the console that the object is created. So what I can do, console.log, I will say object created at, I will say new date dot to date string. Then here this is the function call that I am doing. Now what I have to do, I have to return new class. Of course I created a new class and I added a enhanced functionality, right? Now I should be able to return that class. Now if I return this one, here I should be able to assign it to a variable. So I'll say const advanced employee equals to test employee, and I will, for now I will comment out this one. So here is one employee class definition, and here there is another employee class definition that extends from this employee, but it has an additional functionality of doing a log. So here I am creating one employee object from the main employee class. Now I will create another employee from advanced employee class. So I will say const adv employee equals to new advanced employee. So now what will happen? Now if I save this one, here if you see object created at Friday 18th October 2024. So at this timestamp this object was created. Now from where this log is coming? Now if I comment this out, we will not get any log. Now if I uncomment, we will get the log. So what basically this test function is doing, it is taking one class and it is enhancing its behavior and giving us a new class. And with the help of that new class, if I create the object, I will have the modified or enhanced behavior. So this is the basic concept of decorator. Now to some extent we are able to create the class decorator, but it is still not completed. So what is the next thing? So if you see here employee, and if I say dot, I am getting name. This should also happen for advanced employee. So if I check advanced employee and if I say dot, I am not getting anything. So even if I say dot name, it will give me squiggly because it doesn't know that this name property exists on advanced employee. Why? We are extending it from the class entity here, and here what is the value of class entity? Employee. So this guy should also have the access to this name, but it doesn't have. So let us check that one. So for this, what we have to do, we have to use our good old friend generics. And before that, what I will do, I'll take this particular definition and extract it into a type. So what I will do, I will say type, I will say generic base class equals to, and I will paste it. So this fits any class that you can think of in the TypeScript world. So this is a generic class. Here what I should do, I should create a generic type T that extends from generic base class, and this class entity, instead of having this here, I will say this is of type T, and what this is going to return, this is going to return type T. That means whatever class I am sending, it should be of type this basic generic class. That means any class. So this class entity will become type of this one, whatever I am sending, and I am returning the same but with the field that is being extended here. But what this will return? This will return a new class that has been extended from this class entity which is of type T. So now if you see here also now it started giving squiggly. Why? Because employee is expecting one parameter in the constructor. Now since we are passing this generic T which is same as this employee, now this advanced employee also expects a parameter to be passed to the advanced employee. And if you see here, this name is no more in squiggly. So if I say dot, I'll get the TypeScript suggestion, and also it won't throw error. So essentially what I have done, I have created a employee class and I have passed it to a function which I have called it test. And what this function is doing, this function is returning another class which has all the base properties from the employee class, but it is extending certain behavior or it is modifying certain behavior, and it is returning us another class definition on which I can instantiate a new object, and that object will have same property as that of employee plus the enhanced behavior. So this is all about decorator. So what essentially we have written here, this is a decorator function. Now how to use this one? So here if you see this example, internally not exactly like this but something similar TypeScript is doing. What it is doing, it is taking your test function definition, passing the employee and giving us a new employee so that it will have some enhanced behavior. Now what I am doing here is a manual implementation, and this will happen at the runtime. That means when our code is running, this test function will take the employee and it will give us a advanced employee. Now if I have to use the decorator syntax, what I have to use? I don't have to use it like this, but instead I will use this @ symbol and I will give this test. So this is same as doing this one. Now if you remember, when I'm creating this advanced employee, I'm getting the log. Now what I will do, I will remove all of this, and instead what I'm doing, I'm decorating this test with employee. Now also if you see, I'm able to get the log. So for now I'll uncomment all of this so that our console will be clean. Then what I will do, I will uncomment this so that you can see. Now what I will do, I will do Control S, save. So with this employee itself, without creating this advanced employee, I am able to do a console log. Why? Because of this decorator. What I was doing in this line, same thing is being done here. So essentially what I have written a class decorator, and I am attaching it here as a @ and the decorator name. And same thing I can do for student. Now this is the whole idea of decorator. You write a function that enhances the behavior of the class, and you get a modified class on which if you create object, you will get some enhanced functionality. So this is whole idea of decorator, and this is how we write a decorator function. So we don't have to do this. Instead we can do like this. So what is the difference between these two? Like previously I said, this will happen at the runtime, this will happen at the compile time. So at the compilation time itself, we will enhance the behavior of employee or student class instead of doing it at the runtime. So loosely what I can say, using decorator is kind of a syntactic sugar over doing this kind of thing, where we are calling the function manually, getting a new class and creating advanced object from that advanced class. So this is just a syntactic sugar in loose terms. Loose term means not exactly this is how it happens, but just to have a mental model, you can think like this is how it happens. It's a function that takes a class, it returns another class. From that another class, if you create object, you will have the enhanced capability in that new object. The same thing we do here as a decorator. So I'll remove this line, and since this is doing logging timestamp, I will change this method name or this decorator function name to timestamp, and I will copy it here and I will copy it here. Now every time I create an object, it will log it. So can I do one more object? So I will say employee 2, and no need of this line anymore. So I will change this one. Then if I save it, we will get the log 2 times because we are creating 2 objects. So in real world, you might want to store it to a database or to a cloud service instead of doing it in a console. So this is a very practical example of keeping track of how many objects and at what timestamp we are creating that object. So this is a timestamp decorator. Now you understood what is the reason behind this kind of signature, function signature. So shall we do one more example? So in the previous video in which I discussed about object-oriented programming, I discussed a pattern called as a singleton design pattern. So if you have not watched the video, please watch that video. I have given the link in the description. But if you already understand the concept of singleton, then let us proceed. So what is a singleton class? We will always get the same object from the singleton class. Even if I try to create multiple instances, internally it will point to the same object. So what we will do, we will write a decorator, and if I decorate that with a class, it will automatically convert it into a singleton class. So if you see here, I have employee, I will name it as employee 1. Okay, so I have one employee and I have employee 2. Now since this is not singleton yet, if I compare employee 1 with employee 2, what value I will get? Can you guess? So I will say console.log, I will say employee 1 triple equals to employee 2. So of course you will get false. Why false? Because these two are two different objects, right? Even if they are coming from the same class, they are two different objects, and internally they point to different memory location. So if you compare these two, they will be different. Now if I convert it into a singleton class, it will have one and only one object, and even if I create multiple instances, it will point to the same object or to the same memory location. So my singleton class will be successful if employee 1 equals to employee 2 is true. So let us write a decorator that will convert the class to a singleton class. So what I will do, I will just copy and paste it here so that we can save some typing effort. So here I will say singleton, and this definition will remain same, and this class return will also remain the same. But what I will do, I will say I'll create an instance. So let instance, so this will be the instance in which I'll keep track of how many instances are created. If only one instance is created, I'll return this instance. Otherwise I'll create a new instance and store it here. So this instance will be of type instance type of T. So that means this particular instance, let instance, what is the type of this one? This is a instance type of T. That means with this I should be able to store a new object. So here in constructor, let us remove this line because this is not needed here. Now when for the first time one object is created, the instance variable will be null or undefined. So if not of instance, that means this is the first time that object is being called. What I will do, I will say instance, and here what I will do, so if you see in constructor, I have to call the superclass. That means this superclass holds the constructor of this base class that we are sending this class entity. So here if I do like this super and pass the R and typecast it as instance type of T. So what this instance contains? This instance contains the constructed object of this class entity. And if this is not the case, what I will do, that means I already have an instance object, so I will return the given instance. So if this instance is undefined, I will initialize the instance to this supercall. What this supercall will do, this supercall will create the constructor of this class entity. That means this will have an object of type this class entity. And what will be this class entity? This will be this employee or this student on which we are adding the decorator. And if this is not the case, that means if we already have the instance, we'll simply return the instance. Now if I add singleton, what will happen? If you keep a close eye on this false, and I have marked this class as singleton. Now if I save this one, see, this has become true. Why this has become true? Because now this is a singleton class, and how many objects I create, it will always point it to the same object because of this if else condition. So that's how easily I can write a singleton decorator, and I can add it to any class. And what this will do, this will make the class a singleton class. Very simple, right? So if you see the power of decorators, with one single decorator, I am able to change the entire behavior of the class. Now this is the decorator class. Now there is a concept called as decorator factory. Now what is the meaning of a decorator factory? Here I am not able to pass any parameters. What if I have to pass some parameter? I want to do it like this. Here I want to say timestamp true or false. That means whether I want to log the object creation or not. And this value might be coming from some database config where admin has configured whether the timestamp we should log or we should not log, right? So for now, just let us assume it is hard coded as true or false, but in real life it might be coming from some other variable, from some config or from some database call. So for now, here I should be able to pass a boolean value whether I want to log the timestamp or not. Or otherwise, here what I can do, I can create a constant const, I will say enable timestamp and mark it as true. Like I said, it might be coming from a different source, maybe database or maybe some configuration object. And here I want to pass the enable timestamp value. So how can I do this? Now what I will do, instead of having this function directly, what I can do, I can write another function and name it as timestamp, which takes, I will say allow as a boolean. And what this will do, this will return this function that I have been writing. So what I will do, I will copy this one, or I should cut this one, and I will paste it here, and I can delete this name. This will be just an anonymous function. So here timestamp is the parent function which returns a function that adheres to the class decorator definition. So this is called as a decorator factory. And here now I'll be able to pass the timestamp, and here it will come as allow or not allow. So here what I can do, if allow then only log. So I will cut it and paste it here, and we are getting some error. So why we are getting the error? We are getting the error because here also I have to pass the value enable timestamp. So if you see, now I am getting object created at some particular time. Now I'll change it to false. Now what will happen? Of course it won't log anything, right? I'm just getting the true that is coming from this console log, and from here the logging has stopped. So like this, what you can do, you can pass a parameter that will define or configure the behavior of your class decorator. Now in my previous video in which I discussed object-oriented programming, after discussing the singleton design pattern, I discussed one interview question in which the question was, you have to design a class in such a way that I should be able to create only 5 instance or say 10 instance or n number of instance of that class. And if I try to create say 6th instance or 11th instance depending on the question, so let us say you have to create only 5 objects, and the moment you create 6th object it should throw error. So there I wrote the class which behaves in this way. So it will create only n number of objects. If I create n plus 1th object, it will throw error. Now I am giving this task to you that now instead of writing the class which follows that particular behavior, you have to write a decorator. So if I add that decorator to a class, only n number of objects you can create. After that it should throw error. So I leave that question with you. If you have not watched the object-oriented programming, you can check there. I have discussed this question and I have solved it using the class. Now your task is to do that with help of decorator. And with this, I am concluding the class decorator, and I will see you in the next video in which we will continue our discussion about decorators, in which we will explore decorators on other parts of the class like the property and getters and setters and the class methods. And if you have learned something new, share your thoughts in the comment section. Do like, share and subscribe to the channel, and I'll see you in the next video.